Assalamualaikum and good evening. Today we will discuss about the losses in series and parallel pipe. Previously, we already discussed about how to determine the friction equation, and then we also discussed how to simplify our equation. HF is equal F L over D V squared over 2G into one terms called HF equal K and Q square. So the Q here is actually the constant for the friction. So and then we have two types of pipe. One is series pipe and the other one is parallel pipe. However, these two type of pipe will give you the different total resistance. So for series pipe, we could add all the losses here to get the total losses. However, for the parallel pipe, so we need to use this equation to solve the problems. Sometimes we could rearrange or we could simplify the arrangement of the pipes to calculate the total losses in the pipe. Okay, for example, we have example 1 here. Determine the flow rate at outlet and the percentage of valve opening. So in these problems, we have this arrangement of pipes. There is one main pipe here. So and then from here it's split into two. Pipe here, and then it merge again at this point, and then it flow at certain distance, and from here it split into two, and each pipe end at F and E here. So it will split into half, so means that the outlet flow rate here is 1 over 2Q, and also here is half Q. Okay, so and then the elevation, so we have here the elevation is 100 meter, and then here the elevation is 40 meters, and here the elevation is 60 meters. So means that the flow is actually in gravitational in the gravitational flow. So we could imagine that we have a tank here at 100 meters, so and then it flow until the elevation of 60, and then it will flow until the elevation is 40. So the 40 meters here means the height is 40 meters from the datum. So that is the meaning of this, the meaning of elevation here. So and then it was given that the value of F here is 0.02 for all pipes. So and then the details for the pipe is given here. So the pipe A1B is 30 meters, and then the other pipe is 30 meters, 60, 15, and 30. And this is the diameter of each pipe, and this is the value of K. So here, please make sure that you need to understand here the K value here is, we have the losses is equal to K and Q. So the KQ square. So the Q here is calculated and shown in this table. Okay, so this is the notes. So we know that the K is actually equal to, this is not the K is FL over D V square over 2G. So and then the value of K can be calculated as this one. So this is the idea to calculate the K. So and then in this question, as you see, we have a valve here. So this valve, the equation for the valve here is for this one, 4000 over N cube square. So means that we need to know what is the percentage of the valve opening by calculating the value of N. So this equation is actually valid for this question. So please do not use this equation in another question. Okay, first what we need to do is it is good for us to simplify the flow. So for example, at this junction, so we have the diagram of this, so it split into two and then it merged back. So in this situation, it is a parallel pipe. So for parallel pipe, we could calculate the total losses by using this equation. So mean if we want to calculate what is the total resistance between A to point B here, so we need to calculate as 1 over square root K. KAB here is equal to 1 over KAA1B. So means that we need, here is the calculation of from this point to this point and to this point. So and then for this calculation, we plus with the calculation of from this point to this point and this point. So this belong to here and this belong to here. Okay, so and then we calculate, we substitute the value of K here and then we get this value. Okay, please bear in mind, this value is actually the amount of 1 over square root KAB. Okay, but we want to find what is the value of KAB. So means that you need to solve the mathematical problems here. Okay, so and then you could get the value of KAB is 656. So what we mean by 656, so it means that if we change the formation from this parallel pipe into one straight line here, so mean the resistance at this one is KAB and it is equal to 656. So the resistance between A and B here can be simplified as 656 according to this calculation. So and then the B to C, it's nothing much we can do. We could do because it is just a straight line. So we could calculate, we could merge the AB plus BC by adding the two, the value of the resistance. So AB here is equal to here and this is equal to here. So we substitute the value, so we get 1960. So means that if we simplify the flow from ABC become A to C, the total resistance here is 1960. So and then the flow at point C here will be splitted into two flow. So one, so this is half Q and another one is the half Q. So from here we need to think a little bit creative, so means that we need to calculate separately. Okay, for example, we have A here to C here. Okay, so we could imagine that the total losses here is HA minus HC is equal KACQ square. So and then it is equal to 1960 Q square. So this is the equation for the, as we know that HF is equal to KQ square. So this is the total losses from A to C. So and then we could simplify the diagram. So means now our pipeline become from point A to point C, a straight line here, and then it split into two ways here. Okay. So and then we calculate the head loss between C and F. Okay, so means that HC minus HF is equal to KQ square. So and then according to the table, so the KCF, so mean the resistance for this one is equal to 4,950, but the flow rate here is Q over 2. So we write Q over 2 square. So we have 1,238 Q square. So we have this equation. So from these two equations, so we could calculate HA minus HC is equal 1960 Q2 Q square, and then HC minus HF is equal to 1238 Q square. So from this calculation, so we could get the value of Q. So here, okay, bear in mind the HA here is actually the value of elevation. So why we use the elevation? So if we create the Bernoulli equation, so let's say that we have according to the basic calculation of Bernoulli equation. So we have the pipe here, so A and B. So and then because the velocity is the same, so we have PA over rho G plus VA square over 2G and plus ZA is equal to PB plus VB square 2G and plus ZB and plus losses. Okay, so and then we assume that the uh, the the very simple one is, for example, because let's say the pressure here is almost the same, and then the velocity is almost the same, and then means the obvious changes is actually depend on the height. So means that we could say that ZA minus ZB is equal to the total losses. So that's why we assume that in this situation, so the HC minus HF, so mean the height of this here and here will give us the losses of this section. Okay, so mean that HC, HF actually is the height or the elevation of the pipe. Okay, so we substitute the elevation. So we have the A is equal to 100 meters and F here is 60 meters. So we could calculate the value of HC, mean the height of this center point, the elevation of this point. So we found that HC is 75.5 meters. So and then we could substitute into the equation here. So we could calculate the Q is equal to 0.1118 meter cube per second. So and then we go for the losses between C and E. So C and E is actually the upper part of this one, and the problem is we have the valve here. Okay, so again we will use the same idea. So we compare the height of H and E. So it is equal to K plus KCD plus KDE and Q over 2 square. So and then we know that HC is equal to 75. So and then HE is equal to 40. So we substitute everything, so we could get the value of N here is equal to 0.4244. So means that the valve need to open 42.44% to achieve this situation. So I think you already know the meaning of this valve opening. So normally valve is something like we have a switch here. So we have, for example, it look like this. Okay, so we connect to the pipe here. So if the valve is the holder is straight like this, so means that the flow can go through. But if you change the valve into this one, so this is might be 45 degree, so maybe the opening is 50% opening. So and then if you switch off the valve, you close the valve here, so means that it is 0% opening. So means that at this situation you need to open around 42% to achieve the situation. So the situation here means to make sure that the flow rate will go 50% to the left and 50% to the right.